Giant vase-like sponges, otherworldly jellyfish, segmented worms covered with bristles, and large octopuses are the newest Antarctica discovery. Scientists found them after a giant iceberg had broken away, and it turned out to be a treasury of ancient life under ice. In January 2025, a huge iceberg the size of Chicago, called A84, broke off from Antarctica's George VI ice shelf, which is a large ice shelf about 280 miles long, 12 to 43 miles wide, and around 820 feet thick. In the summer, which lasts from November to late February, the ice shelf melts at the surface, and meltwater ribbon lakes form. They're elongated and ribbon-like. That's how they got their name. Anyway, when the iceberg floated away, it left part of the ocean floor wide open, and it was a spot no one had ever seen before. Scientists on the research ship Falkor 2 were nearby in the Bellingshausen Sea. As soon as they heard about the iceberg, they immediately changed their plans. They understood that it was a super rare chance to check out something unknown and amazing, like lifting a rock in the forest to see what's hiding underneath. The researchers used an underwater robot named Sebastian and explored the deep sea for 8 days. They went as deep as over 4,200 feet. Down there, they found a hidden ecosystem. There were big corals and sponges literally packed with sea animals. A whole world under the ice. The researchers thought they'd find some life down there, but they didn't expect to see so much. And this underwater ancient life wasn't just surviving, it had been thriving in that harsh, icy place for a really long time. Anemones that looked like fluffy little trees, sea spiders, ice fish, octopuses. The research was live streamed to scientists from all over the world, and those live streams are actually in open access. The coolest thing was that some discovered creatures seemed to be new species. Yes, there are probably new species in Antarctica in 2025, and some might only live in this region. That's because Antarctica isn't just really far away. It's been cut off from the rest of the world for millions of years. The Antarctic circumpolar current surrounds it, like a big water moat surrounding a castle. But even if it turns out that those species are not new, the scientists have still found snails, worms with bristles, crustaceans, like tiny crabs and shrimp, and a species of the phantom jellyfish. Those are super rare and look otherworldly. Their official name is too complicated, so let's just call them the giant phantom jelly. This jellyfish is huge. Its bell, the round umbrella part on top, can be more than 3 feet wide. It has 4 long arms that trail behind it. Each one as long as 33 feet, about as long as a school bus. Scientists first caught one way back in 1899, but it took them 60 years to realize it was a totally new kind of jellyfish. The phantom jellyfish has a see-through purplish body that looks kind of ghostly. Instead of normal jellyfish tentacles, it has these ribbon-like arms that help it catch food and pull it into its mouth right in the middle. Even though jellyfish don't have brains like we do, researchers watching the giant phantom jelly noticed something surprising. The otherworldly creature seemed to move its arms very carefully and with control, especially when swimming through tight spaces on the seafloor. It looked like it was being very cautious and deliberate. Ugh, creepy. Another sentient being? Jellyfish have a simple nerve net instead of a brain, which helps them sense the world around them. But the way this phantom jelly moved made scientists think it might be smarter or more coordinated than other jellyfish. Studying it can help scientists learn how animals without brains still manage to explore and survive in tricky places underwater. Another cool find was little worms called bristle worms. Scientists call them polychaetes. But let's stick with bristle worms because it kinda sounds fun. Lots of different kinds of them live in super cold, deep parts of the ocean. Bristle worms have bodies made of many segments, and they have tiny little bristles all along their sides. These bristles help them move around, feel what's near them, and even protect themselves from danger. One cool example is the Antarctic scale worm. It's a type of bristle worm that lives in really cold, deep waters and has shiny, golden bristles that make it look pretty fancy. During Antarctic deep-sea exploration, the team also found giant sponges shaped like vases. Usually, sponges grow very slowly. So to get that huge, they must have been growing there for a really long time, maybe even hundreds of years. Their size shows that the deep-sea animals living around them didn't just move in recently. Those sea creatures have been there for decades and managed to form thriving communities under the ice. So, it really was ancient life hiding under all that ice. And that surprised scientists a lot. In older studies, people used to drop cameras through holes in the ice or visit iceberg areas long after the ice had broken off to explore hidden ecosystems. Back then, they mostly saw bare, empty seafloor with just a few living things. But this time, the team arrived just weeks after the giant iceberg broke away, and they got to see what was hiding right underneath it. The first 9 miles behind the ice shelf can hide rich and busy ecosystems. The area is dark, cold, and hidden for ages, and still, all kinds of creatures live there. This shows that life can survive in places that seem too harsh or frozen for anything to live. On the other hand, finding all this life down there isn't super surprising. Lots of animals live in dark, cold places underwater, so it makes sense that they'd be under the ice shelf too. The ice kind of hides them and keeps them safe from anything going on above. But what's weird is how many different kinds of creatures live there, even though it used to be a really closed-off space. It actually looks a lot like the seabed in parts of Antarctica that don't have ice on top. How can that be? Usually, tiny plants called phytoplankton grow near the surface where sunlight hits. Little shrimp-like animals called krill eat those plants at night. When krill get full, they sink down and bring food and nutrients to the ocean floor. Even their waste helps feed the deep-sea creatures. But if there's a huge ice cap above, sunlight can't get through, so no plants can grow there and no krill bring food down that way. Scientists thought this would mean less food and fewer animals down there, but they found a lot of life anyway. Turns out, food and nutrients probably sneak in under the ice, carried by underwater currents, kind of like rivers flowing under the ocean. Scientists found some animals that lived a long time, so it looks like those currents, which mostly come from melting glacier water, bring enough food to keep the ecosystem healthy and full of life. No one really knows what's going to happen to all that deep-sea life now that the iceberg has floated away. Those creatures have lived under the thick ice for who knows how long, in super stable, pitch-black conditions. Obviously, they're not exactly fans of change, so losing that icy roof might totally mess with their whole setup. One of the scientists mentioned that the ice shelf the iceberg came from has been creeping backward, like 25 miles over the last 50 years. That's a part of a bigger pattern. Antarctica's ice is melting faster and faster, which pushes sea levels up around the world. That's why this Antarctica discovery matters. The team's trying to figure out not just what's happening now, but how this hidden ecosystem fits into the bigger picture. If we can understand how this place is changing over decades or even centuries, maybe we can predict what's coming next. And it's pretty amazing that breaking ice can tell us so much, right?
So, some scientists drilled through the seafloor off the U.S. East Coast only to find more water. But this time, it's the kind of water we can actually drink. And that's a big deal, because this new freshwater reservoir could supply a metropolis the size of New York City for the next 800 years. Now, the team is confused. They're trying to figure out how a giant freshwater system ended up under the ocean, and more importantly, how it stayed hidden from us for over 20,000 years. Okay, to be fair, scientists have suspected there's fresh water under the seafloor since the late 1960s. But only recently, researchers actually got on a boat to follow up on those reports. They named the mission Expedition 501, and they had one goal: drill to the bottom of the ocean and see what was really hiding down there. So those scientists drilled about 1,300 feet down off the coast of Massachusetts, and once they got that deep, they hit a thick layer of sediment that was basically soaked with fresh water. Now, that freshwater layer sat below the saltier sediment, and above it, there was a tight lid made of clay and silt, material that doesn't really let water pass through. This seal is strong enough to keep the two layers separated. So, up top, you got seawater, and down below, fresh water. The drilling process took about 3 months. In that time, they pulled up 13,200 gallons of water from 3 different spots beneath the seafloor, just off Nantucket and Martha's Vineyard. They're still analyzing the results, but early reports suggest this reservoir might be much bigger than they previously thought. It could stretch from offshore New Jersey all the way north to Maine. Now, despite its size, it did a pretty good job hiding from us. Now, scientists are trying to figure out when and how this reservoir was formed. And back in 2003, one study suggested fresh water could get trapped under the ocean in at least 3 different ways. Theory number 1: tall mountains near the ocean can funnel rainwater straight down from higher elevations and into the seabed. Theory number 2: a hidden reservoir can form if sea levels stay very low for a long time and rainwater seeps into the ground. Then, when sea levels rise again over hundreds of thousands of years, that fresh water can get trapped in the sediment underneath. And theory number 3, which is connected to the one before, is that a freshwater reservoir can form under the ocean when ice sheets grow and sea levels drop. At the bottom of the ice sheet, the ice slides over solid rock, known as bedrock. As the ice scrapes and grinds against this rock, it creates heat, which melts some of the ice. That melted water collects at the base of the ice sheet. Then, because the ice is extremely heavy, it pushes the water down into the ground. Over time, the water gets trapped under layers of sediment. Well, more than 20 years later, scientists are finally close to an answer. The mountain theory is basically ruled out here because of the geography of New England. There are no large high mountain ranges right next to the coast. But the glacier theory could make sense. Their hypothesis is that the fresh water in this reservoir came from glaciers at some point during the last ice age, which lasted from about 2.6 million to 11,000 years ago. Still, it's not a final answer. The team is now studying the reservoir in much more detail. They're still analyzing things like microbes, rare earth elements, and the pore space in the sediment. All of that can help researchers estimate the reservoir's size more precisely. The age of the sediments can also narrow down when exactly it formed, and knowing its origin will help reveal how those systems have evolved over time. We just have to wait a little longer. But one thing is certain, there really is fresh water under the ocean. And when you think about that, it's hard not to wonder, wouldn't some salt get mixed in? And yeah, that can happen. So let's take a look at the map. Here's the reservoir. The farther you go from the coast, the saltier the water gets, and that doesn't matter much to us because it's not safe to drink anyway. But the closer you get to the coast, the less salt there is. The drill site closest to Nantucket and Martha's Vineyard showed that out of every 1,000 parts of water, only 1 part is salt, so it's considered safe. You can drink it, cook with it, and take a bath in it. But why does all of this actually matter? Well, because fresh water is becoming a big problem around the world. I mean, the lack of it. A new United Nations report talks about a global water bankruptcy. They say we've hit a new and pretty worrying stage. More and more river basins and underground water sources, called aquifers, can't go back to their historical normal. Droughts and shortages are becoming more permanent, completely changing what life looks like in some places. For example, the Aral Sea. This was once the world's 3rd largest lake and looked like this back in the 1980s. And this is how it looks today. it's completely dried out. It's not just there. More than half of the world's large lakes have lost water since the early 1990s. And Central Europe has lost 39% of its glacier ice in little over 20 years. So even now, over 1 billion people around the world still don't have access to fresh water. And estimates say that in just 5 years, demand will be 40% higher than supply. That's why this finding is such a huge deal. It doesn't mean we're about to start pumping water from under the ocean tomorrow. But it does mean we might have backup options in the future, especially for big coastal cities. That's exactly the goal of Expedition 501. And it's not just in the U.S. This group is part of a much larger international science program called the International Ocean Discovery Program, or IODP. Their goal is basically to drill deep into the seafloor to understand how Earth works, its climate, its geology, and in this case, its hidden water systems. This expedition came after decades of unanswered questions. Like we mentioned earlier, researchers had hints of fresh water under the seafloor for decades. Those hints came from strange electromagnetic signals and seismic data. But back then, the technology just wasn't good enough to confirm it. So the idea stayed on paper for a long time. Everything changed when modern drilling came into play. Expedition 501 literally drills straight down through the seafloor and pulls up sediment samples. And this process normally takes days to months. Is it safe, though? Well, they say the ship that carries the drilling rig follows international rules to protect the environment. They're also taking every precaution to make sure no solid or liquid material is dumped into the sea during the work. Their new finding off the East Coast is only the beginning. For now, it's the largest one of its kind. But scientists believe there may be still many hidden reservoirs out there around the world. Similar expeditions are planned or already happening near other parts of the world. Soon, scientists might find new reservoirs off the coasts of Indonesia, Australia, and even South Africa. So, Expedition 501 is basically about mapping these hidden freshwater reservoirs and finding out how they form, how stable they are, and whether we can protect them. Because, yeah, they still have a huge technical problem ahead, which is making sure the fresh water doesn't mix with the salty water above and below it. And that really matters if we ever want to use this water in the future, or avoid contaminating aquifers that already exist near the coast. So this expedition is pushing scientists to find answers to a pretty uncomfortable question. If fresh water gets harder and harder to find, what options do we really have left? So, what do you like to listen to? Music? Podcasts? Maybe the sound of rain or the crackling of a campfire. But what about listening to the ocean? Not the familiar crash of waves on the shore, but sounds captured deep on the cold ocean floor. Sounds that send chills down your spine. Sounds of something big, dark, and possibly alive. And the most unsettling part is this. The true nature of some of these sounds remains a complete mystery to this day. In 1997, something strange echoed through the Pacific Ocean. Deep beneath the surface, far off the coast of South America, a sound appeared so powerful that it instantly unsettled scientists. It was ultra-low in frequency, massively loud, and unlike anything recorded before. The signal was later given a simple name: the Bloop. At first glance, the Bloop sounds harmless, almost playful, but what it represented was anything but. It was so intense that it could be detected by sensors nearly 3,000 miles away. Imagine standing in New York and hearing something happening in Los Angeles. Now imagine that noise traveled through deep ocean water, terrifying marine life and oceanographers. Whatever produced it had to be enormous. The signal carried patterns that felt like its source was some living creature. Whales were the first suspects, but even the blue whale, the largest animal in the world, simply couldn't generate a sound that loud. The numbers didn't add up, and that's when speculation took over. If something could produce the bloop, it would have to be larger than anything swimming in today's oceans. People began imagining creatures of impossible size, ancient sea monsters, the kraken. Some even whispered about the megalodon, a prehistoric giant shark thought to have gone extinct millions of years ago, and featured in dozens of videos right here on the bright side. The mystery only grew deeper when scientists mapped the approximate location of the sound's origin. It came from a region close to Point Nemo, the most remote place on Earth. This spot in the Pacific Ocean lies more than 1,000 miles away from the nearest land in every direction. It's so isolated that it's often called the oceanic pole of inaccessibility. Point Nemo is a place few humans will ever see. Because of its remoteness, it has become a kind of graveyard for defunct satellites and space debris. When spacecraft are decommissioned, they are often guided to fall into these waters. It's quiet, empty, almost untouched, and yet something powerful had screamed from nearby. For fans of cosmic horror, this detail felt oddly familiar. In the fictional universe of writer H.P. Lovecraft, the ancient sunken city of R'lyeh lies beneath the ocean near this very region. According to the stories, R'lyeh is where the monstrous entity Cthulhu sleeps. It's a powerful, scary, intelligent creature lying dormant for thousands of years, ready to awaken and bring about the end of the world. Of course, Cthulhu is pure fiction. Lovecraft never claimed otherwise. But once the internet made the connection, the idea took on a life of its own. But science eventually caught up. The Bloop recording is still easy to find online. You can listen to it yourself. But it sounds so innocuous that you'll probably be disappointed. And today, we know with certainty that it didn't come from a living creature. Researchers later confirmed that the sound was produced by ice, specifically by an ice quake. Now, ice quakes occur when enormous icebergs fracture, crack, and break away from glaciers. When this happens, they release tremendous amounts of energy, generating ultra-low frequency sounds that can travel across entire ocean basins. These sounds are similar to biological calls, especially when recorded from far away and distorted by water. In fact, scientists compared the bloop to other known icequake recordings and found striking similarities. The source wasn't a monster. It was Antarctica itself during shifting, breaking, and reshaping. For many people, this idea brought mixed emotions. On forums like Reddit, some openly admitted they preferred the idea of a giant unknown life form. Yup. Another strange sound was captured in the early 1980s, deep in the South Pacific, during a scientific expedition near New Zealand. Researchers were exploring the South Fiji Basin, where the ocean floor lies more than 2.5 miles beneath the surface. There were short, sharp, repeating noises echoing through the water. 4 distinct bursts, each one sounding uncannily like a duck's quack. So, researchers called it the Bioduck. The sound was rhythmic and consistent. Eventually, the team concluded that the source had to be biological, but identifying exactly what made the sound proved impossible. After sharing the data with colleagues in Australia, did they realize something even stranger? Similar sounds had been recorded in other parts of New Zealand and Australian waters. Decades later, the mystery remains unsolved. Some scientists believe the quacks may not be random at all. They could be a form of communication. Perhaps the sounds may come from Antarctic minke whales, though no direct proof exists. Scientists also noticed that there were several sources of sounds, and when one source spoke, the others fell silent, as if they were listening. It may have been a conversation echoing through the deep, in a language we still don't understand. Imagine a terrifying alarm blaring inside a secret laboratory, announcing that a monster from another planet has broken free. It's an ugly sound, loud, piercing, and oppressive, the kind that makes your skin crawl. In August of 1991, scientists recorded something eerily similar. Not in a lab, but deep beneath the Pacific Ocean. Across vast areas of the ocean, a strange, repeating signal began to appear at different times. It consisted of narrow, rising tones that lasted several seconds each. Researchers named this sound Upsweep. It's detected most often during the spring and fall, leading scientists to believe it may be connected to seasonal environmental changes or changes in the source itself. But what exactly was producing it? No one knows for sure. The only thing scientists can say with confidence is that Upsweep appeared near areas of suspected volcanic activity. But if this sound is natural, why does it seem so precise, so consistent? It almost feels artificial, as if a secret underwater facility is periodically broadcasting a distress signal from the depths of the ocean. Since its discovery in 1991, the Upsweep signal has gradually weakened, making it one of the strangest and most unexplained phenomena ever recorded beneath the ocean. Now, there's another mysterious sound known simply as slow down. True to its name, this signal steadily decreases in frequency over 7 minutes before fading into complete silence. It was recorded in May 1997 on a hydrophone array located in the eastern equatorial Pacific Ocean. At first, slow down doesn't seem especially loud. But here's the chilling part. It was picked up by 3 separate sensors placed nearly 3,100 miles apart. Imagine how deafening and terrifying it was near the source itself. So, what caused it? The most widely accepted theory suggests that a massive drifting iceberg slowly came to a stop and ran aground. The idea is surprisingly plausible. A colossal block of ice is scraping along the seafloor, grinding forward until it finally halts. The location supports this theory as well, since the sound originated near shallow waters and small islands. Because of this, many scientists classify slow down alongside the bloop as a cryogenic noise caused by ice. Still, it remains just a theory. Officially, the sound has never been identified. And there's yet another eerie recording from the ocean. This one sounds like a moan, but scientists named it whistle. Go figure. It was recorded in 1997 and gives the unsettling impression that something enormous is sitting on the ocean floor and whistling. Researchers believe that something could be an underwater volcano. When they compared the whistle signal to previously recorded volcanic sounds from the Eastern Pacific, they found them very similar to each other. Most likely, all these sounds are of a natural source, volcanic eruption or iceberg collision. But it's still pretty scary to hear something like this while driving. It would be especially unpleasant to be directly above an erupting underwater volcano. Well, yeah.
At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini-world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lihir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, icefish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic circumpolar current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future.
For millions of years, something has been lurking in the depths of the ocean. You can't see it, touch it, or map with sonar, yet it keeps entire species trapped where they are. Recently, scientists uncovered its victims, strange jellyfish cousins that look almost identical, except for one odd detail. One travels the world's oceans, the other is stuck in the Arctic, unable to escape. What blocks its way? It's not ice, not land, not even depth, something far stranger. Let's take a look at this mystery. The jellyfish in question belong to a subspecies with a pretty complicated and hard-to-pronounce name, so I won't. See? Anyway, they live very deep in the ocean, about 3,300 to 6,600 feet down. That's so deep that sunlight doesn't even bother showing up there. The strange thing is that some of these jellyfish have a little bump or knob on top of their umbrella-shaped body, and others don't. And this tiny difference decides their entire life story. Jellyfish with a knob are world travelers found across all oceans. Jellyfish without a knob are stuck in the Arctic, like they're grounded for life. To figure out what was going on, scientist Javier Montenegro and his team looked back at more than 120 years of jellyfish photos and sightings. Then they added in modern DNA testing. The results were curious. Genetically, the knobless and knob jellyfish in the Arctic were identical to knob species in the western Atlantic. In any case, This bizarre similarity aside, only the knobless jellyfish are trapped in the north. So, what's keeping them from leaving? It's not a giant underwater wall or a rocky barrier. Instead, scientists think the wall is biological or linked to geography. Just like something called the Wallace line, nature's invisible border. So imagine sailing on a boat in Indonesia, crossing from the island of Bali to the island of Lombok. It's only about 22 miles, not even enough for a long nap on deck. Once you're there, the beaches look the same, the weather feels the same, and the palm trees all sway the same way. But when you look at the animals, it feels like stepping into a different universe. Birds, mammals, even reptiles suddenly don't match what you just saw a short distance away. That invisible line dividing the two worlds is the very Wallace line. The story began in 1859. Alfred Russel Wallace, a British naturalist, traveled through the East Indies. While hopping between islands, he noticed something that didn't make sense. On the western islands, like Borneo and Bali, the animals all look like they belong to Asia – monkeys, tigers, woodpeckers, the usual. But east, the animals seem to have come straight out of Australia. Marsupials, cockatoos, even kangaroo cousins. The two sides weren't blending at all. Wallace realized that a narrow stretch of water could act like a massive biological border. How could two islands, close enough to see across the water, host such different wildlife? The line is not just some quirk of nature, but the result of powerful geological forces. Between the islands, there are underwater trenches that have never dried up, even when ancient sea levels rose and fell. To the west, you can find the Sunda Shelf. That's an enormous sunken platform that once connected Asia to nearby islands. That's why Borneo, Sumatra, and Java are packed with Asian-style wildlife. To the east is the Sahel Shelf. It once linked Australia and New Guinea, helping Australian species spread. The Wallace line slices right between these shelves. This part of the world, the Indo-Australian archipelago, is where four massive tectonic plates slam into each other. As the seas rose, animals became trapped on islands. When seas fell, some species made it across, but not so many. That's why two islands, separated by just a short boat ride, ended up with completely different ecosystems. The Wallace line isn't some recent discovery. This invisible border has been messing with animals for millions of years. Now, back in the Pleistocene, when giant mammoths roamed our planet and the oceans were up to 400 feet lower, many of the islands in Indonesia were actually connected. Tigers and elephants could stroll from place to place without ever touching water. But even when sea levels dropped that much, Asia and Australia never linked up. There was always a stretch of really deep water between them, and that watery gap acted like an uncrossable wall. For more than 50 million years, it's been stopping animals from mixing, keeping Asia's lineup on one side and Australia's weird crew on the other. That middle zone of islands, the ones stranded between the two continents, is called Wallacea. Only animals that could swim, fly, or somehow make it across the open ocean managed to live there. Everyone else was stuck at home, no exceptions. As you see, there can be a logical scientific explanation for almost any phenomenon on Earth. Maybe we could find one of those poor trapped jellyfish. Apparently, the problem lies in the North Atlantic Drift. It's a warm current that flows up from the Gulf Stream. Scientists don't know exactly why, but something about this area blocks the knobless jellyfish. One theory claims that predators beyond the drift are too dangerous for these creatures. Another idea is that the knob itself somehow gives jellyfish an edge in survival, but no one really knows. For now, it's like an invisible border. Knob jellyfish pass, knobless jellyfish stay put. On the Pacific side of the Arctic, there's no need for a mysterious barrier. The Bering Strait already does the job. On average, it's only 165 feet deep, which is way too shallow for deep-sea creatures to get through. So these jellyfish, knob or no knob, can't escape south. And since we're back at the topic of animal life, Let's speak a bit more about the weird fauna quirks of the Wallace Line, because animals are the easiest way to see this barrier in action. Birds, for example, often refuse to cross even the tiniest gaps of open water, so their species stop right at the line. Mammals are even stricter. Bats can cross because they fly, but larger land animals never made the jump. On the Australian side, it's all about marsupials like kangaroos and possums. You'll also find native rodents that settled there more recently. On the Asian side, you get a different cast: apes, elephants, tigers, cats, monkeys, rhinos. Sure, there are some oddball exceptions. Sulawesi, right in the middle of the divide, has macaques, pigs, and big-eyed little tarsiers. But overall, the split is obvious. Step off the boat, and the animal world changes completely. But then, what about plants? Well, they don't always follow the rules as neatly. Seeds can hitch rides on birds, float on water, or get blown by the wind. But even here, the Wallace Line shows up. Take eucalyptus trees, for example. They're as Australian as kangaroos. Almost no species make it across to Asia. There's just one exception, which somehow popped up on Sulawesi and the Philippines. That's the magic of the Wallace Line. Two islands can look the same climate, same forests, sometimes even close enough that you can see across the strait. But their animals are like night and day. And it's all because of an invisible border in the sea that's been in place for millions of years. Such discoveries might sound small, but they're important. They show us that there are still hidden boundaries in the ocean that humans don't understand. These invisible fences could explain how marine animals spread, evolve, and survive. As scientists put it, finding two different body shapes inside a single genetic family shows how little we know about jellyfish and other gelatinous creatures. As for the Wallace Line, even today, it stands as one of the most fascinating mysteries in biogeography. It reminds us that life doesn't always spread evenly. Sometimes, a short stretch of water can act like an uncrossable wall. There's a lot more mystery in the deep sea than we thought. You'll never believe this. Wait, maybe you will. Scientists have discovered stolen treasures worth $138 million on the ocean floor near Madagascar. Well, whatever. Let's be honest. It gives you little pleasure to hear about treasures that you'll never get. However, the story surrounding this find is just like an action movie. So here's the scoop about it. So let's see. Well, count them. 400 precious stones, including 110 diamonds and 250 emeralds, gold and silver bars, expensive silk, coins, relics, and many other valuable items. Even now, it seems like a jackpot. But for the 18th century, it was a real fortune, about $138 million by today's standards. In early 1721, sailors loaded all this stuff into a Portuguese treasury ship called the Nossa Senhora do Cabo. That's a mouthful. The Viceroy of Goa and the Archbishop of Goa also stepped on board. After that, the vessel sailed from Goa to Lisbon. The ship had not only economic but also diplomatic value. You probably already feel that something bad is going to happen to the boat. Well, good guess. Now, go buy a lottery ticket. During the voyage, the ship faced a severe storm. The waves rocked the ship and flooded it with water. The wind shook the masts. To increase their chances of surviving, the ship's crew needed to reduce the weight. Therefore, they began to dump their cargo into the sea. There were artillery shells among this cargo, and they were necessary for protection in case of enemies. It seems the crew didn't realize what a critical mistake they had made, but at that moment, they needed to stay alive. The ground appeared ahead. It was the island of Réunion. There, the ship waited out the storm and was ready to move on. But then, another, more serious problem appeared. On April 8th, the ship, I'll call it the NASA from here on, met pirates. Of course, the boat with such valuable cargo should have been equipped with powerful means of protection. But almost all of those were thrown overboard by the sailors during the storm. They had little chance of getting out of that mess alive. The pirates they faced were among the most dangerous pirates in history. And you know why? Because their leader was Olivier the Buzzard Levasseur. Now, let's take a small sidebar because it wouldn't be enough to say only a few words about Levasseur. The Buzzard was one of the most mysterious and terrible pirates in history, worse even than the dread pirate Roberts. People are still trying to solve the mystery he left behind, but more on that later. Now, what do you think is the normal life story of any pirate? Let's see, they were probably born in poor neighborhoods and grew up in poverty and brutality. They were used to getting what they wanted by threatening people, so they started plundering ships on the seas and oceans. Well, Olivier Levasseur wasn't like that. According to some stories, he was born in the north of France sometime between 1687 and 1690 into a rich bourgeois family. He had everything people of that time could ever dream of: well-off parents, a home, food, and a good education. He dreamed of becoming an architect, a priest, or a naval officer. In the end, he chose something close to the third. From 1701 to 1714, there was a great conflict in Europe. Different countries tried to control the Spanish Empire. During this difficult period, the French king, Louis XIV, gave Levasseur a letter of marque. From that moment on, the future pirate became an official privateer of the French crown. Now, roughly speaking, a privateer is also a pirate, only working for his country. A privateer could use his vessel to attack enemy merchant vessels and had to share the spoils from those ships with the royal treasury. So Levasseur became a legalized pirate. The king provided him with a good ship and finances for effective work. According to legend, while serving the king, Levasseur got an eye injury and began wearing a blindfold. That's when the classic image of a pirate with a black eye patch appeared. But this story is a legend. Probably. Levasseur learned how to rob other people's ships quite effectively. His toughness and skill helped him get a lot of treasures. At some point, he didn't want to share the loot with his country, so he decided to turn from a privateer into a free pirate. In addition, he dreamed of long-distance voyages and adventures. He wanted to rob ships not only in European waters, but in the far reaches of the Caribbean and South America. His pirate life lasted about 15 to 17 years. According to stories, in the beginning, he joined the crew of English pirate Benjamin Hornigold. He also collaborated with Samuel Black Sam Bellamy, one of the richest pirates in history. He robbed ships along with the famous Edward Teach, who you probably know as Blackbeard. Having spent a lot of time with such famous pirates, Olivier Levasseur himself became famous for his thoughtful attacks, knowledge of maritime affairs, and compliance with the pirate code. There's a pirate code? More like guidelines. He ensured the order, discipline, and behavior of the crew. Thanks to this, he managed to commit one of the most daring robberies in history during the encounter with a Portuguese ship, Nasa, etc. So the pirate hijacked the ship and grabbed all its goodies. The Viceroy of Goa and the Archbishop of Goa were also captured. The pirate released the Viceroy later for a big sum, but the fate of the Archbishop and the rest of the passengers remains, well, unknown. After that, the pirates sailed with the loot to the island of Sainte-Marie. In the 18th century, it was a place that no European colony paid attention to. There was no authority there, which is why pirates adored this crossroads in the Indian Ocean. Dozens of pirate crews used this place as a hangout. The anchorages of this island were located close to the main sea routes. This meant that pirates could quickly board their ship and set off to plunder vessels and then return. The fate of the Nasa and its valuable cargo remained unknown. For more than 300 years, researchers and historians have been trying to find the treasure and have only recently come closer to the answer. The ship wreckage was found near the island of Nosy Baraha in a harbor about 400 miles west of the place where the pirates had attacked the ship. Using sonar and remote sensing, experts created a map of the seabed and found fragments of a ship similar to the wreckage of the Nasa. They also found artifacts nearby. There were many wrecks of other ships in this region, so it took more than 2 decades to identify the find. Fortunately, the scientists were able to confirm that they had found the legendary ship. They discovered more than 3,000 objects and fragments that indicated that the wreckage belonged to the merchant vessel. Chinese porcelain, sculptures, ceramics, European coins, African shells, exotic spices – all this ended up on the seafloor. But where are the treasures that the pirates took? No one knows. But fortunately, we all have the opportunity to find out where one of the biggest pirate caches of all time is located. In 1724, an amnesty was granted to all pirates who sailed in the Indian Ocean. The French king freed them from persecution in exchange for the pirates sharing the loot. Levasseur didn't want to share with anyone and hid in a highland in the Seychelles. From that moment on, the hunt began for him. Levasseur managed to hide from the French authorities for several years, but then he was caught in Madagascar. On his last day, July 7, 1730, Levasseur ripped a necklace off his neck and threw it to a crowd of people. He said, "Find my treasure, the one who may understand it." The necklace contained a mysterious cipher which, according to the pirate, could lead to his hidden treasure. The cargo of the NASA, worth $138 million, was far from the only loot. But where can we find all of it? Well, people are still trying to solve the mysterious cryptogram of Levasseur. However, many think that the story about the cipher is a fake. The first reports about it appeared only in the 1930s, so maybe it's all made-up rumors. Or… Over 1,500 people lost their lives in this part of the ocean, so maybe it's a prudent idea to stay away from it. The spot where RMS Titanic sank remains dangerous. I mean, yeah, there are still huge icebergs out there, but there are even bigger threats lurking beneath the surface. Titanic is sitting about 12,500 feet underwater, nearly 400 miles southeast of Newfoundland. It's been down there for over 100 years. So, over time, the wreck's just been falling apart little by little. The infamous ship is rusting just like any iron or steel structure would be underwater. Chemically, when you mix iron, oxygen, and water, that combo sets off a reaction that creates iron oxide, and that's what leads to corrosion. So, steel plates, beams, all that stuff is getting weaker. Parts of the liner are caving in, like the ceiling in the captain's bathroom and a section of the railing that collapsed not too long ago. But in the case of Titanic, a lot of that corrosion is actually being caused by iron-eating bacteria. When the Titanic sank, it split into two big pieces, the bow and the stern, which landed nearly 2,000 feet apart on the ocean floor. And now both pieces are covered in this biofilm, a living blanket of bacteria, marine fungi, and all sorts of other microbes. Over time, microbes feeding on the ship's iron have created these things called rusticles, and they are actually speeding up the wreck's decay. Scientists say the stern is breaking down way faster than the bow, mostly because it took more damage when the ship sank. And now, thanks to all that bacterial activity, the stern could be deteriorating as much as 40 years ahead of the bow. So yeah, microbes have been thriving and flourishing down there. If you are a germaphobe, that probably sounds like a total nightmare. But honestly, it's not that bad. For one, they don't even look gross. These rusticles actually look kind of cool, like ice crystals or tiny diamonds clinging to the wreck. And don't worry, you are not in danger. As long as you keep a safe distance from the wreck, no direct contact, and definitely don't go poking around inside, there really is no risk. Speaking of getting dangerously close, we've got to mention the Titan submersible disaster. You know, the one that catastrophically imploded back in 2023 during a trip to the Titanic wreck. Sadly, all 5 people on board lost their lives. Even though this trip was sold as a tourist adventure, going that deep in the ocean is no joke. It's terrifying, cold, and dark. Sunlight gets absorbed by water and can't reach much farther than about 3,300 feet below the surface. Past that point, the ocean is in total darkness all the time. Titanic lies within a region known as the Midnight Zone for this very reason. The few brave people who have visited the wreck say the descent takes over 2 hours through complete darkness. Then, out of nowhere, the ocean floor just pops into view, lit up by the submersible's lights. The second big challenge is actually finding the wreck. At that depth, navigating is no easy task. When you reach the bottom, you really don't know exactly where you are. You're just kind of fumbling around in the dark. knowing that Titanic is somewhere down there, but you can't see it. However, detailed maps of the Titanic site, made from decades of high-res scans, really do help. As the wreck starts to come into view, they can use those maps to stay on track. Plus, sonar and sensors let the crew notice features and objects even if they're way beyond the sub's tiny light pool. For example, the Titan submersible had a sensor called the Doppler velocity log. This one sent out sound waves to measure how fast the sub is moving and how deep it is, based on its distance from the ocean floor. Still, passengers on previous trips to Titanic in this submersible have said how tough it is to find their way once they reach the ocean floor. And we can't forget about the pressure. The deeper you go in the ocean, the more pressure the water puts on everything. And the pressure is crazy high at the Titanic's wreck site. To put it into perspective, it is about 200 times the pressure inside a car tire. That's why submersibles need super thick walls to handle it. So yeah, the water around Titanic has creepy microbes, pitch-black darkness, and insane pressure. But there is one more thing happening down there, and that's unpredictable currents. You're familiar with them. I mean, when you swim in the sea, you can usually feel the currents pulling you from side to side. But the deep ocean has its own set of underwater currents too. They're not as strong as the ones you feel on the surface, but they can still move massive amounts of water around. These currents can be caused by things like wind, differences in water temperature and salt, and even strange storms down on the ocean floor called benthic storms. They can get intense and stir up the sea bottom. Now, like I mentioned earlier, the Titanic wreck is in two big pieces, the front and the back, and researchers have been checking out the seabed of the surrounding area. One part of the wreck is near this cold underwater current called the Western Boundary Undercurrent. It flows south and moves mud and sand along the ocean floor, creating ripples and patterns that show how strong or weak the current is. Most of the time, the currents there aren't very strong. They even found sand ripples near where all the Titanic debris landed, like furniture, coal, and just random stuff from the ship. And those ripples are showing a current flowing from east to west. But inside the main wreck site, things get a little wilder. The water flows more from northwest to southwest, probably because all the huge chunks of the ship are messing with the flow. Around the south side of Titanic's bow, the currents get unpredictable too. They keep switching directions, from northeast to northwest to even southwest. It's like the ocean's just doing its own thing down there. Experts think that over time, all this shifting water is going to slowly bury Titanic under layers of mud and sand. Little by little, the wreck could just fade away and disappear beneath the ocean floor. Alright, now it's time to get to the obvious issue here – icebergs. Yep, they're still a problem for ships today. In 2023, around 380 icebergs flowed into the busy shipping routes between North America and Europe. That's a problem. You see, the bigger the iceberg, the easier it is to spot and avoid. Smaller ice is a lot harder to detect, though it's no less dangerous. And that's because the most dangerous part is underwater, where no one can see it. Think about the iceberg that sank Titanic. Passengers saw about 100 feet of it above the water, but it's believed that's only 16% of its total size. Experts say the rest, hidden beneath the waves and much larger than what's visible, could stretch down several hundred feet. Now, the good news is that, unlike Titanic's day, we have much more technology now to spot icebergs in time. Modern ships have radar and satellite imagery that can pick up icy threats hiding in the dark. Some vessels even use sonar and thermal imaging to see through fog, helping the crew to spot icebergs above the surface. GPS and AIS pick safer routes, and monitoring centers around the globe send out real-time alerts, like having a personal iceberg spotting assistant. So, yes, it is a massive upgrade from just relying on binoculars. You won't have to worry about icebergs on your next cruise vacation, even if it passes alongside Titanic's route. But just to be extra safe, try not to travel with anyone named Jack or Rose. And never, never play the violin while on board. Just saying.
Off the coast of Croatia, archaeologists have recently uncovered something incredible. A perfectly built stone road, still intact, buried under layers and layers of mud. It's almost 7,000 years old. Who built it? Why? And where does it lead? This road might have been lost forever, if not for sheer luck. Back in 2021, archaeologists were looking at satellite images of the island of Chicxulub, a little Croatian island in the Adriatic Sea. Suddenly, they noticed some strange shapes, odd patterns, half seen beneath the waters. Curious, they dove into the waters to check it out. That's when they uncovered something incredible, a sunken Neolithic settlement, the village of Solin. But the ancient village was just the beginning. In 2023, while exploring the site further, archaeologists found something even more breathtaking. A perfectly built stone road, still intact, buried under layers of sea mud. It was thousands of years old. The road is only 13 feet wide. It's laid carefully, stone by stone, a ghost of a forgotten world stretching across the seabed. This was no accident of nature. The stones were too precisely shaped, too deliberately placed. And somehow, across 7,000 years of storms and tides, both the village and the road survived. One of the scientists said it's a miracle. The islands around Chicxulub shielded the coast from massive waves. This spared them both from destruction. They also found something else: ceramic fragments and flint knives, small whispers of the people who lived here in the past. But who were they? The mysterious road goes way back into the Stone Age. An ancient culture called Hvar culture lived on the Hvar island nearby. But they also spread across the eastern Adriatic coast and built the village of Solin just offshore from the coast of Chicxulub Island. The road connected the village to the main island. If you set foot on Hvar Island today, you'd see a fascinating island of pine forests, lavender fields, and sunlight that spills across vineyards. But you'd also be stepping into a living mosaic woven from 7,000 years of history. Neolithic people lived there around 4,900 BCE. That was before the rise of cities, before the pyramids of Egypt, before history even had their first kings. These people found shelter in the island's caves. In local places like Grabcheva Cave and Markova Cave, they crafted delicate, painted pottery, some of the oldest in Europe. This ancient settlement once bustled with life, perched near beaches where now only waves roll. The people who built it walked barefoot over its stones, carrying baskets of grain, tools, and clay pots filled with water or olive oil. Among those little shards, archaeologists discovered something amazing: the oldest depiction of a boat in all of Europe. Even in 3,500 BCE, the people of Hvar were dreaming of journeys beyond the horizon. And even though the Neolithic farmers of Hvar culture didn't have great technology, they had already learned to tame the earth. They built megalithic stone tombs, raised circles of rock in nearby Gradina Bay, and crafted intricate flint blades and stone axes. Why are Solin village and the road underwater now? We don't know for sure. Perhaps something happened to them in the past that caused this. In any case, the road and Solin are all we have remained from those days. Hvar Island was always a fascinating place to live in. The island's history is rough and beautiful, carved by rebellions, pirates, and foreign kings. Around 385 BCE, the Greeks sailed across the sea and found this beautiful island. A high limestone ridge, hidden freshwater springs, and fertile plains kissed by the sea breeze. No wonder they decided to settle here. These Greeks themselves came from Paros, a sunny island in the Aegean Sea. When they got to Hvar Island, they found a town they called Faros. They weren't being super original. Now we know this town as Stari Grad, which means Old Town, and it actually is one of the oldest towns in all of Europe. They brought with themselves deep knowledge of farming, sailing, and city building. This helped them to do something extraordinary. They divided the land into perfect geometric squares, neat fields for vineyards, olives, and grains. This perfect patchwork of farms is now called the Starry Grad Plain, and it's still so pure and unchanged after more than 2,000 years that it became a UNESCO World Heritage Site. Later came the Romans. Their villas and roads now also threaded across the hillsides. Then came the Croats. Their traditions, from religious processions to the haunting ancient songs of Holy Week, have survived the passing of centuries. But it was under the Venetians, which was about the 15th century, that Hvar truly blossomed. When the Venetians came there, they chose Hvar town as a major port. They built fortresses and arsenals, cathedrals, theaters, and squares. It was the golden age of Renaissance, and Hvar brought three genius giants of Croatian culture to the world. The first one was Petar Hektorovic. He captured the life of fishermen and the spirit of the sea in his epic Fishing and Fisherman's Talk. In a local castle, the Tvrdalj Castle, his stone villa still guards its secret fish pond. The second one was Hannibal Lukic, who wrote The Slave Girl, the first secular drama in Croatian culture. And finally, Martin Benetovic, a painter, musician, and playwright who left his mark on the island's soul. In the Franciscan monastery by the sea, there's a beautiful painting stretching across an entire wall, The Last Supper. Not the original by Da Vinci. This one is thought to be created by Matteo Ingoli. Same theme, but a different artist, though this work is considered a Renaissance masterpiece. Back then, Hvar Island became a jewel of the Venetian Empire, a naval stronghold, and later, a stage for Renaissance poets. But this place wasn't always peaceful. In the 16th century, the Ottoman Empire came here. Their corsair raiders swept across the sea and wanted to conquer the island. Hvar's people built fortresses that still cling defiantly to the cliffs, even to this day. Napoleon also came here, but even all this couldn't drown Hvar's spirit. Life always returned to the fields. Lavender bloomed purple over the terraces, rosemary and olive trees tangled the hillsides, and wine flowed from vineyards that the Greeks once planted. And still, the culture lived. In the 17th century, the island founded something unheard of: the first ever public theater in Europe. Before, theaters were meant for kings and nobles alone, but this one was a place where commoners and nobles sat together beneath carved stone arches, watching plays lit by candlelight. The locals also founded the first ever professional European Tourist Association. Tourism began early with the formation of the Hygienic Society of Hvar in the 19th century. Today, Hvar is known as the Island of Lavender and is crowned the Queen of the Dalmatian Islands. In the square of St. Stephen, the Cathedral of St. Stephen rises. Its bell tower, also built back in the Renaissance, once warned of Ottoman raiders. In the Benedictine nunnery, unseen by any but a few, the sisters weave agave lace. The threads are pulled from the agave fibers, knotted into impossibly delicate patterns, each one unique, each one a prayer captured in cloth. High above the town, you can still see the ancient cannons aimed out to sea, and below them, the glittering sweep of the Pakleni Islands, looking like little emeralds. There's more sunlight in a year than almost anywhere else in Europe, and the rich history in every festival, in the beauty of the Holy Week processions, and in the old songs that drift on the sea breeze. Look, the sea is glowing from within. It's stunning, yet eerie at the same time. White glow covering a huge area of the sea surface is not what you expect to see on a dark night. You look at one of the scariest and mysterious phenomena in the ocean. Let's study it. On January 30th, 1864, the Confederate ship CSS Alabama was sailing southwest along the Horn of Africa when the crew members noticed a mysterious white glowing sea. Captain Raphael Semmes described it as a sickly and unearthly glare of a phantom sea. Although Semmes was a stern and fearless sailor, he was scared by this bright water in the middle of the dark sea. At first, the crew thought they had been sailing over some kind of flooded ridge. They threw a weighted line, which immediately sank to the seabed several hundred feet down. Obviously, the mysterious glow was not a ridge. For several hours, the ship sailed through this eerie glowing sea, and then, suddenly, this bright region ended. The Alabama entered the usual dark waters. Captain Raphael Semmes' description was one of the very first documented accounts of a mysterious and elusive phenomenon called the Milky Sea. In 1851, in the famous book Moby Dick, this phenomenon was described as a sailor's quiet, superstitious fear at the entrance to the midnight sea of milky whiteness. Jules Verne, in his novel 20,000 Leagues Under the Sea, described this phenomenon more scientifically. One of the characters of his book said that the whiteness was caused by the presence of myriads of infusoria, a sort of luminous little worm, gelatinous and colorless. For centuries, people have reported mysterious glowing water at night, and only recently have scientists got closer to solving this mystery. But first, let's be clear. What Captain Raphael Semmes saw was slightly different from that violet-blue glow called bioluminescence. Aristotle wrote about luminous algae and phytoplankton in the 3rd century BCE. He noticed that sometimes the water produced bright blue flashes when he hit the surface of the sea with a baton. In 1492, Christopher Columbus observed unusual flickering of light in the ocean caused by bioluminescent marine worms. As it turned out later, those worms rose to the surface to perform a circular mating dance. In the late 1800s, scientists discovered that bioluminescence is the result of an oxidative reaction inside certain animal and plant cells. You might have seen it at night while walking along the shore. If not, you can watch a video with bioluminescent water on the internet. But milky seas are a slightly different phenomenon. The sea glows white as if it's illuminated by a bright spotlight, and the area of white water can extend for miles. Unlike bioluminescence, milky seas are a rarer and quite elusive phenomenon, which is why it was so difficult for scientists to determine its nature. People didn't come across such glowing waters very often, so many regarded it as legends about mermaids or sea monsters. But in 1985, science got a chance to study this thing in more detail. That year, a U.S. Navy research vessel got into the Milky Sea while sailing near the Arabian Peninsula. There were scientists on board who collected some samples of milky water and conducted a laboratory analysis. And that's what they found out. The water contained bioluminescent bacteria, but what caused them to glow? Scientists suggested that algae colonies first rose to the water's surface. They began to bloom and gradually decompose. Those cells of rotten algae burst and release special substances, lipids. A huge number of bacteria began to feed on lipids and multiply rapidly. The number of bacteria grew in such large numbers that they began to produce a continuous white glow. But where exactly and under what conditions could these milky seas appear? It was necessary to know not only for scientists, but also for authorities. Such a bright spot in the water could reveal the outlines of a submarine and turn it into an easy target for enemies. So scientists continued their research. One of them was atmospheric scientist Stephen Miller. He started studying milky seas in the early 2000s and made a breakthrough in his research. To begin with, he decided to find out if the sensors on space satellites were capable of seeing bioluminescence. Miller started looking for any mention of extensive milky spots on the internet. He came across the Frontier Science portal, where people wrote about strange and unexplained phenomenon around the world. There, he found a report from the British merchant ship SS Lima, which hit the Milky Sea in January 1995 while sailing along the Horn of Africa. This is how the log entry described the event. The bioluminescence appeared to cover the entire sea area from horizon to horizon, and it appeared as though the ship was sailing over a field of snow or gliding over the clouds. After that, Miller collected the images taken by certain satellites over the place where the SS Lima sailed at that time. At first, he didn't notice anything strange. But later, he realized that he was looking directly at the Milky Sea. The area of the glowing spot was so large that he had to scale the image down. That's when he saw a spot that looked like a comma. The edges of this spot coincided with the place where the crew of the SS Lima saw the white glow. Miller studied the images of this area taken before, during, and after the encounter, and found out that the Milky Sea rotated counterclockwise to the local ocean currents. But most importantly, Miller now knew that the White Sea could be seen from satellites. In 2011, 2 satellites with more sensitive sensors, capable of seeing in poor light, entered Earth's orbit. They helped Miller and other scientists to find out that Milky Seas appeared most often in the winter and summer in the northwestern Indian Ocean and around Indonesia. Great! Now Miller had the place and time to work with. He analyzed satellite data for the period from 2012 to 2021 and found out that one of the largest Milky Sea incidents occurred in 2019. For 45 nights, a white glow covered 40,000 square meters, which is the approximate area of Kentucky. But even after all these studies, scientists haven't managed to find the exact cause of the white glow. In addition to the idea about the disintegration of algae, researchers have put forward a theory that the glow may be caused by quorum sensing. This is the ability of bacteria to communicate using chemical signals that produce light. Okay, let's say there's some truth to this, but why are they doing this? To find out, let's look at classical blue bioluminescence in other organisms. Some biologists suggest that with the help of the glow, bacteria attract partners for reproduction. Another theory claims that the bright light works as an alarm when dangerous enemies appear in the sea. For example, a colony of phytoplankton meets hungry fish. The organisms turn their glow on to attract larger fish. It's like using evil to fight another evil. There are many theories, but what's the problem with figuring out the exact reason? Even with all the satellite help and studies of Milky Seas, it's quite difficult to get to the right place at the right time. Let's say a white glow the size of a football field appears in the sea. The satellites notice this and send a signal to the research center. Next, a team of scientists boards a vessel and goes directly to the place. The distance to the Milky Sea can be quite big. And by the time they arrive, the glow has already disappeared. In an ideal situation, scientists need to be around the area before, during, and after the glow to get the full picture. Unfortunately, this is not possible at the moment.
Roofs fly off like paper, huge trees are yanked from the ground, power lines snap and leave neighborhoods in the dark. Streets flood like rivers, homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole, a huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up
are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, 2 thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual. And that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the US could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the US. The risk moves around depending on the time of year and the weather.
Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light-years wide. For comparison, just 1 light-year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around minus 63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-Spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we've found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system.
Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank one bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But, to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this, a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, That's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the 2 regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades Volcanic Water Reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
Well, here you are. You're getting into your submarine, feeling a bit anxious. You're going to descend hundreds of feet underwater to explore the ocean floor. So many things can go wrong. Technical issues, insane water pressure, dangerous marine monsters, mysterious eerie sounds. Wait, what? Eerie sounds so deep underwater? Yep, a strange humming noise is coming from the ocean depths. What makes it even creepier is that it only appears during dusk and dawn. This noise might act as a dinner bell, since it's likely to have a connection to massive groups of sea creatures moving up and down through the water to feed. But so far, it's just a theory. Using highly sensitive underwater microphones, researchers recorded a mysterious low-frequency hum at depths of 660 to 3,300 feet. The sound wasn't very loud, just 3 to 6 decibels above the usual ocean background noise. For comparison, when someone is whispering in a quiet library, the sound reaches 30 decibels. The underwater noise also had a puzzling or humming quality. The weirdest thing? Despite their efforts, the researchers couldn't pinpoint a single species responsible for the sound. The noise originates in a region known as the Twilight zone of the ocean. This region is dark and doesn't have many nutrients, with no sunlight for photosynthesis. Life here relies on organic debris falling from above, such as deceased organisms or waste material. At the same time, while it may sound barren, the Twilight Zone is far from empty. A 2015 study estimated that up to 90% of the world's fish could live in this zone, including many undiscovered species. Now, back to the mysterious noise. The researchers believe the sound may be linked to the vertical migration of small marine creatures like fish, shrimp, and squid. These animals move upward toward the surface at sunset to feed on plankton and nutrients, using darkness to avoid predators. At sunrise, they return to the depths to hide. This migration, which is one of the largest animal movements on Earth, involves billions of organisms and occurs daily. Scientists suspect that the strange hum might occur during this migration, as a way for the creatures to communicate or coordinate their movements. It might also serve as a signal to indicate when it's safe for a group to go to the surface and feed. If some animals indeed use the hum to communicate, it could help us understand deep-sea life better. The Twilight Zone has always been considered a quiet environment, but such a discovery hints at complex social behaviors and interactions among its inhabitants. But it's not only the ocean that produces bizarre sounds. Earth is humming non-stop too. Unfortunately, you can't hear this soundtrack. This hum isn't from earthquakes. It's produced by subtle ongoing vibrations in the planet's crust. They're too faint for us to feel and can only be detectable with special equipment. Scientists have long known about this phenomenon called free oscillation and have recorded this persistent hum. Earthquakes are the most noticeable ground movements. According to the U.S. Geological Survey, Earth experiences about 500,000 earthquakes every year. Of those, only 100,000 are strong enough to be felt, and around 100 cause noticeable damage. But in the quieter moments between earthquakes, The planet is still constantly vibrating with smaller, unnoticeable movements. Unlike the sudden jolts of earthquakes, this hum is steady and uniform, and it's a byproduct of microseismic activity. Seismometers, tools used to record ground vibrations, can detect this sound anywhere on land. For years, researchers have been debating the origins of this hum. Some thought it came from ocean waves reaching deep into the seafloor. Others believed it was caused by colliding waves on the ocean's surface. By 2015, scientists had confirmed that both factors contributed to Earth's constant vibration. And although this hum has been recorded on land, now we also have much clearer, more detailed underwater recordings. To study the hum, researchers used spherical seismometers on the seafloor in the Indian Ocean near an island east of Madagascar. Between September 2012 and November 2013, they placed 57 free-fall seismometers across a 772 square mile area. These devices are designed to sink into the ocean floor and record even the faintest vibrations. Over the course of the 11-month study, the team filtered out noise from ocean waves and seafloor currents. They got clear, consistent signals of Earth's hum, with peaks at frequencies between 2.9 and 4.5 MHz, far below the range of human hearing, which starts at 20 Hz. The discovery of Earth's hum from the ocean floor is more than just a scientific curiosity. It gives researchers a new way to study how energy moves through the planet's crust and mantle. In any case, the world around us is filled with weird sounds that sometimes remain unexplained. One of the most intriguing examples is the Bloop, an incredibly loud underwater sound recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The sound lasted about a minute and began as a low rumble, which then increased in frequency. It was so loud that underwater microphones detected it across an astonishing 3,000 miles. Initially, some experts thought it was the call of a massive unknown sea creature. However, NOAA later determined that the source likely had been the calving of icebergs, when giant pieces of Antarctic glaciers had been breaking off and crashing into the sea. The sound, known as Julia, a strange cooing noise, could have been produced by an iceberg scraping along the ocean floor. Another sound, dubbed train, due to its resemblance to the sound of train wheels on a track, likely originated in Antarctica's Ross Sea. Then there is Upsweep, a recurring seasonal scratchy noise detected in the Pacific Ocean since 1991. Despite years of research, its exact cause remains unclear. The underwater world also has bizarre sounds that can be described as choirs of fish. Scientists studying marine life off the coast of Port Hedland in Western Australia discovered that many fish species sing in synchronized choruses at dawn and dusk, much like birds. Over 18 months, researchers recorded tons of sounds, including foghorn-like calls from black jewelfish and rhythmic ba-ba-ba sounds from batfish. These fish songs, which often involve repetitive calls that overlap in large groups, are especially important for breeding, feeding, and territorial behavior. Deeper in the ocean, NOAA researchers also explored the sounds of the Challenger Deep, the deepest part of the Mariana Trench. They used a titanium-encased microphone that managed to survive the crushing pressure, over 1,000 times the atmospheric pressure at sea level. Over 23 days, the recorder captured loads of noises, from the haunting songs of whales to the rumble of distant earthquakes. Now, we've already figured out that the ocean is filled with strange sounds, but you can also hear weird noises above ground. One of the most puzzling is the hum, a low-pitched noise reported by people in specific areas, such as Taos, New Mexico, or Bristol, England. The sound is often described as a faint engine-like drone, and its source remains a mystery. Some researchers think it might be a psychological phenomenon, where people focus on subtle background sounds they might otherwise ignore. In any case, no definitive answer has been found yet. Geological formations can sing too. Utah's Rainbow Bridge, a massive 300-foot-high sandstone arch, vibrates like a guitar string when exposed to sounds, distant earthquakes, or waves near Lake Powell. Scientists have studied its frequencies to understand how such vibrations could affect the bridge's stability over time. Interestingly, visitors to the Rainbow Bridge have reported hearing faint humming sounds too. The skies also have their own eerie noises. For centuries, people in polar regions have described faint sizzling, popping, and cracking sounds, accompanying auroras. A Finnish researcher made the first known recordings of these sounds and traced their origin to electrical discharges in the lower atmosphere, about 230 feet above the ground. These charges, caused by magnetic storms fueling auroras, produce faint sounds during calm and clear nights. Other natural phenomena, such as icebergs grinding against the seafloor or volcanic activity on the ocean floor, produce groans, rumbles, and crackling sounds that scientists study to learn about glacial movements and underwater geological activity. I myself produced many unusual sounds and rumbles, but, that's a subject for another video, or my next annual review.
In some regions of the Pacific Ocean, ships sink very easily, which is why it is feared by many sailors. Although there are many routes in that area, there are some that few dare to risk because crossing them can mean facing extremely dangerous forces of nature. If you need to travel from Asia to America by ship, the most obvious route would be the shortest and quickest. That is, a nearly straight line under the North Pacific Ocean. But instead, it might be better to avoid crossing this place and opt for longer and more expensive but much safer routes. There is not one, but several reasons. The Pacific is home to some of the most dangerous waters in the world. When we open a world map, we usually see that the Pacific Ocean is kinda divided, which prevents us from realizing how big it is. But in reality, this giant covers almost a third of Earth's surface. It's about 10 times larger than the smallest ocean in the world, the Arctic Ocean. In other words, when crossing it, the chances of being cut off from any landmass are very high. And in cases of emergencies, mechanical failures, or even storms, help might take days or even weeks to arrive. This significantly increases the risk of serious accidents, the possibility of cargo loss, and, in more serious cases, something even worse. Now think about it. A ship journey from Santos, Brazil to Cape Town, South Africa covers a little more than 3,400 miles. To get from Callao, Peru to Shanghai, China, you need to travel around 10,000 miles. Another major problem that prevents sailors from crossing the Pacific is storm systems, whose name already indicates what they contain: unpredictable and therefore dangerous storms. In addition, near the equator, there is a chain of winds called trade winds that directly influence the climate in the tropical region and occasionally cause rain. Trade winds are strong and constant winds that act like a whirlwind that rotates without stopping. And although they are extremely important for nature, as they spread moisture through forests and even influence the formation of deserts, they pose a problem. Their intensity changes depending on the season. In winter, for example, they can be much stronger. And since these winds are responsible for moving the ocean waters, they also create strong sea currents that could make the journey much more dangerous. In 2015, researchers came across a series of extremely strong winter trade winds that caused a surge of short but intense waves in the Pacific Ocean. They observed that those waves began to hit the ship with constant force, as if they were repeatedly punching it. As a result, the hull structure was completely twisted and deformed. And in the end, they confirmed what they had already known. Those waves, caused by winter trade winds, could be a real threat to vessels. And by the way, do you remember that help in the middle of the Pacific can take a considerable amount of time to arrive? So, now there is much more than one reason behind the hostility of the winds. Such a large ocean doesn't have many geographical barriers, such as mountains or large islands. It means that there are no land structures around it that could hold back or slow down the winds and currents.
So the trade winds and ocean currents have complete freedom to gain strength and speed. This explains why the Pacific is the scene of powerful storms and giant waves. This is different, for example, from the North Atlantic, where North America, Europe, and Africa help to contain and redirect the atmospheric and maritime systems. It is now very common for scientists to see the bottom of the Pacific Ocean as a giant jigsaw puzzle because it's literally full of moving pieces. It's home to the largest number of tectonic plates on the planet, and one of them, the Pacific Plate, is the largest maritime plate that science has ever identified. This particularity makes the region extremely unstable to earthquakes and volcanic eruptions. Even though the ocean may seem calm at first glance due to its geology, things can change very quickly. This makes it unpredictable and treacherous. For example, in 2022, the cargo ship 1 Apis was crossing the ocean, 1,600 miles northwest of Hawaii, when it was caught in a torrential storm. As a result, more than 1,800 containers were damaged, falling to the bottom of the sea. Hundreds more collapsed on the deck, turning into a real-life steel domino due to the force of the wind. The captain managed to steer the ship to Japan. The journey lasted about a week, and it was only when they got there that they understood the extent of the loss. But it wasn't just the 1 Apis. The following year, the ship Maersk Essen lost about 750 containers, while the Maersk Eindhoven lost more than 260. In both cases, the routes were bound for Asia. These three alone have already accounted for much more than the global annual average of containers lost at sea, which is about 1,382 per year. And the most curious thing is that these events happened in winter. Speaking of winter, it was in the winter of 2020 that the Pacific made history. Scientists recorded a 58-foot-high wave in the ocean, which is equivalent to the height of a 5 or even 6-story building. In general, a wave is considered giant or extreme when it's more than twice the height of the others around it. This one, however, was almost 3 times bigger than the rest. Now, it's important to remember that despite being rare and scary, these waves are not a tsunami, as they're caused by wind. Tsunamis, on the other hand, usually occur after underwater earthquakes or volcanic eruptions. Another big monster of the Pacific are typhoons, and the 2024 typhoon season confirmed this. One of the highlights was Hurricane Christy. It did not touch the crust, meaning it did not cause direct damage, but we cannot underestimate it. Christy reached Category 5 on the Saffir-Simpson scale, which is the maximum level. A hurricane of this degree is considered catastrophic, so it's no wonder that it was powerful enough to generate huge waves and extremely dangerous rip currents. In addition to this, there was also Super Typhoon Yagi, which hit the Asian continent with such force that it gained the reputation of the most powerful in the last 70 years. When it arrived in Vietnam, it caused around $1.6 billion in damage, destroyed infrastructure in several cities, and left a trail of victims wherever it went. As if that weren't enough, the Pacific is also home to one of the most unstable regions on the planet, the famous Pacific Ring of Fire. It's a huge, crack-shaped area that's home to intense volcanic and seismic activity. It's the most tectonically active place in the world, as the plates of the Earth's crust are constantly moving there. They move apart and collide, or grind against each other, which causes the region to experience earthquakes and volcanic eruptions all the time. Seismographs record some type of tremor there every 5 minutes. This dangerous region is responsible for about 90% of the planet's earthquakes. So, 9 out of 10 tremors occur within this ring, which stretches across the northern Pacific. And the worst part is that it doesn't just affect North America or Asia. In 2023, tremors linked to the Ring of Fire were felt in several Latin American countries, such as Argentina, Chile, Ecuador, and Peru. There was a trail of destruction, and the lives of around 15 people were lost. There's no shortage of reasons for ships to avoid the shortest route across the Pacific and opt for longer routes. As the popular saying goes, prevention is better than cure.
Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it Bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher pitch signals, which they named Biogoose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on Bioduck and Biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the Bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The Biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike Bioduck, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the Bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the Bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the Bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet Upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nater crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nater crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nater asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA's keeping an eye on. It's called Bennu, and it's about the same size as the Nater impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700, but still, it's a reminder that Earth is always in the cosmic firing line.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time,
This mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly.
but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Guess what? A huge ocean might be hidden deep beneath us, about 250 to 400 miles down, and it's bigger than any ocean on Earth's surface. Scientists were listening to earthquakes deep within our planet and noticed how these shakes slowed down when passing through certain parts of the mantle. This suggested that water was there. Models and experiments led them to uncover the underground ocean. But this ocean isn't like the typical water you imagine. It's a lot crazier. The mantle is a thick layer between the Earth's crust and core. It consists of the upper mantle, the lower mantle, and a mysterious layer between them called the transition zone. In the upper layer, we can often find a fascinating material called olivine, which got its name from a pretty greenish color. Olivine doesn't care about high temperatures and thrives in lava comfortably. It not only thrives, but it even makes up 50% of the entire upper mantle. We can find this stuff on Earth thanks to volcanoes. When volcanoes spew their magma out, all the minerals in it make their way to the surface. As magma cools and solidifies, it forms igneous rocks, and the minerals start to crystallize. Olivine is one of the first minerals to crystallize, and since there's so much of it in magma, it forms lots of crystals. Sometimes they're small, but sometimes they grow large and become very noticeable. We collect these large gemstones and use them to make pretty accessories and for other purposes, such as casting metals. But as we dive deeper within the Earth, about 250 miles down, things get strange for olivine. We enter the mysterious transition zone. The pressures get way higher, and the temperatures rise significantly. Here, olivine transforms into beautiful rock called wadsleyite and ringwoodite. Just like with olivine, we sometimes find them thanks to volcanic activity. Both are blue-green with a beautiful glassy appearance. Unfortunately, they're exceedingly rare and small, so you can't make accessories out of them. They're usually studied in labs. But they can do something that olivine can't. Thanks to their structure, they can act like a sponge, soaking up water. Now, this doesn't mean that they're literally wet. Rather, wadsleyite and ringwoodite can store water components, hydrogen and oxygen, within their structure. Usually, up to about 3% of them are water particles. These two little guys play an immense role in our planet's geology. They influence how the Earth's mantle conducts electricity as well as its viscosity, or how well it flows. This affects mantle convection, plate tectonics, and even volcanic activity. Without these tiny crystals, our planet would be completely different. The world could be mostly underwater, with just a few mountaintops visible. They also help us better understand how water works in general. So the transition zone is special because it's hydrated. Here we come to the recent discovery, a massive underground water reservoir. Scientists try to understand how water behaves in this deep part of the Earth. They discovered that as water-rich ringwoodite moves even deeper into the Earth to the lower mantle, it can start to melt a bit. This means it can release a bit of water and then trap it somewhere underground instead of letting it move around freely. But this released water wouldn't really be in its liquid, solid, or gas forms. Instead, it would be chemically bound to the underground structures. So, it won't be an ocean in the traditional sense, but there might be a vast amount of water down there. This finding is super important because it changes the way we understand Earth's water cycle and resources. It turns out that water isn't just found on the surface, but also moves through hidden spaces deep inside the planet. Another fascinating thing we discovered about water is that it might exist in a mysterious fourth state of matter. Now, we're used to thinking of water in its three common states: solid, liquid, and gas. But under extreme pressure in tiny spaces, it can enter a mysterious fourth state known as tunneling. We discovered this strange behavior in the mineral called beryl. Within beryl, there are super small six-sided channels, just about 5 atoms across. Turns out these channels act like tiny cages that can trap individual water molecules, like wadsleyite and ringwoodite. In these conditions, the water molecules start showing behaviors that are closer not to classical physics, but to quantum physics. Quantum tunneling allows particles to exist in multiple places at once or pass through barriers they shouldn't be able to. Imagine a ball that somehow ends up on the other side of a hill without climbing over it. It just goes through the hill. Hydrogen atoms in beryl are like tiny balls. Typically, each ball would sit in one specific spot. However, in the experiment, these hydrogen atoms didn't stay still. Instead, they were found simultaneously in multiple spots. Together, they formed a pattern that looked like 2 wavy rings. It's like water molecules got smeared around in a ring shape. This is a state of water that we've never seen before. It reshapes our understanding of how water behaves under certain conditions, and it has huge implications for biology. All these discoveries have everyone rethinking where Earth's water really comes from. Water is essential for life as we know it. About 71% of Earth is drenched in water, and humans are mostly water too. When we figure out how it appears in space and on planets, it will give us clues about how to better search for extraterrestrial life. One theory says that when Earth was forming, the materials that clumped together to make the planet already included water, or at least the ingredients to make it. Earth formed about 4.5 billion years ago. Our planet slowly emerged thanks to gravity from dust, gas, and rocks that surrounded our newborn sun. This material gradually came together to form the planets of our solar system. However, the young inner solar system was a scorching place, too hot for any liquid water to survive. It would have simply vaporized and escaped into space. But it's possible that water was trapped inside the rocks that initially formed Earth. Some of the Earth's original building block contained much more hydrogen than all our oceans combined. It would also explain how water molecules got so deep underground. Then, volcanic activity could have later released the water stored deep within, sending it into the atmosphere as vapor. This vapor would eventually cool down, condense, and fall as rain, filling the young Earth with lakes and seas. Another idea is that after Earth was formed, water was brought here by wet space visitors like comets and asteroids crashing into the planet. Long ago, the inner solar system was a wild and chaotic place, much like Brightside. When the outer planets rearranged their orbits, this caused a ripple effect, which we now call the Late Heavy Bombardment. It sent a flurry of icy space rocks crashing through the inner solar system, many of which collided with Earth. For a while, scientists thought that this event and comets were a primary source of Earth's water. But then, we learned that comets have a different chemical makeup from the water on Earth. Then we looked at the asteroids. Their water closely resembles the water in Earth's oceans. Some of the samples even contained organic materials. There's also a chance some random planet helped us out. About 4.5 billion years ago, a Mars-sized planet named Theia is thought to have collided with Earth. It was a violent encounter that melted part of Earth's mantle and led to the formation of the Moon. Perhaps Theia also brought some water with it. And finally, Earth could have generated its own water. Chemistry says that hydrogen could react with molten rock in vast magma oceans to produce seas and oceans. It's also possible that all these ideas are true, and Earth's water came from several sources. It complicates our research, but shows how dynamic water can be in space. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano, sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animal's response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, Eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.